Good afternoon again. Yet another instance of our high-load topics and yet another presentation. And this time, I'm happy to invite on stage Anton Zhukov from ManyChat, and he will tell us about well, the 2% solution, a title rather mysterious one, so we'll happily listen to that. Please welcome.
Oh, yeah, it's going. Okay, hi everyone. My name is Anton, and today I will tell you the little story about our customer data storage development. But before, a few words about me and ManyChat. So, the main points about me you can see on the slide, but most important about this presentation in the last one. This presentation will be about high-loaded systems, performance engineering, and fail-safe solutions. And of course about ManyChat. ManyChat is a marketing automation platform which helps our customers to make their conversation easier using Facebook, Instagram, WhatsApp, Telegram, email, and SMS. We have more than 1 million businesses connected to ManyChat. We work around all the world, and we have a great team works in 3 countries, Armenia, Spain, and US. And we have a ton of conversations. And about conversation we will tell today. So this is use case of our event databases. We have a specific live chat based on our system for our customers who can speak and chat with their subscribers using the system with bot messages and native people messages. We use our event databases to store messages, internal events, any actions, additional information, and technical states. So it means that we have a lot of events, a ton of events. And our table looks like this. PosgtreSQL relational database with the 64 terabytes of data. That's just only one database, first in the call chain. And this events really rarely requested, and this price in an AWS instance, it's more than $10,000. To be crystal clear, $10,000 it's a price for a smallest of our database. It's the first database 4 years before. 4 years before. And that's like our databases lineup looks. You can see that our main database of events works in read-write mode. That database is actually recurrent. If you have any cases in your career with the live chat and store any messages of your clients, you know that most important database is the first one. Right one in the slide, because you have a last messages, and when you're chatting with somebody, you are reading last messages in this list. And of course, for previous messages, you just have another databases which you're using before. Each database has 1,000 charts, and each database have a little different size. Upper of each database you can see a percent. And for the first one, read-write database, we have a 96% of requests. And that's most important thing because we are working with this further and often. The next one, 3.3%, and the last one, which we need to migrate, less than 0.1%. And that's really interesting case because we have the same price for the first one database and the last one database. That means that we pay same money for a database which we use for 96% and less than 1%. And that's not so interesting case, and we need to solve it. So the first engineering thing, just remove users data. This is the first idea which can go into our head, and that's a very often case when we just decide to clean data. Remove users data, but after our discovering, we had a low impact of this effect because we had a lot of users data. It's like technical events, and that's a lot, but it's really small because actually good messages, it's real messages instead of technical events, have a big content. But technical messages using just a state, this is maybe event type or any short, interesting data. Next one, remove all data of free accounts. I know that's a usual practice for these companies, which has a ton of data, and that's a really ordinary case when company like Facebook, Google, Amazon, and even more little companies make an interesting decision about just cleaning free account data, remove all free accounts and clean after that. But for us, that's not an interesting way because we are not so big and we don't have a ton of free accounts with users' data. And this is a little dirty and questionable way because our customers believe in us, they trust us, their data, and we try to avoid this. The next one, of course, just change the database. The world has a lot of interesting databases which contain and collect data in compressed state and really have a compact engines to store it on a disk and any efficient decisions. But this is a little dirty for us because we have one important principle for our infrastructure. We try to make our decisions easier to understand and to support. That means that we're using short list of technologies with a high expertise instead of a wide list of technologies with ordinary expertise. That's very important to avoid useless share of expertise, prepare engineers, and making a lot of local meetups to explain how it works and how you should support it. It's like when you use 20 technologies with ordinary expertise, you have 20 fail points potential. And obviously, this is too risky. We don't have a big company in a complete understanding. You already saw that we have just 140 persons in our team. And we use it to support and develop all of our features right now. And it's really easy when you have a short list. So, not our way. And after that, after all of decisions, we really ask ourselves, what do we have actually, really? And we need just change the data storage because PostgreSQL is a relational database with a lot of effects of allocating this storage of using indexes, and this is 100% uptime for we should to pay. We just need to decrease the data size, and after that, we will decrease the costs. So, our targets. In the list, you can see that we have a lot of features relational to an ordinary database. But this is still data storage. By what and why? We need to parallel stateless component. We need to fast access by scope. I just don't continue to explain you everything on the slide because we need something looks like database in data storage, and we still under high load, so we need a fast and stable decision, but with a very low price, and that's most important. That's most important for us. So our way looks like this. We still have event databases, but we will change the last one relational database to a cold storage, and it should be last in a cold chain just to a comfortable migration. Actually, this storage may have any position in this list because this is stateless storage, and we can use it like a database. But for really comfortable migration, we place it on the last one position and continue migration. So, and interesting point that we can still work with both of these storages during the migration because these databases has same result sets. Because we have a same event sets in a cold storage and in relational database, we can continue working with both of them. When you try to selecting events about messages, you just requiring and querying from a database events after some event ID. In the first request, you just going the first 50 messages, for example, but next request will be with give me please 50 events after this event ID. And because of already selected any events from a relational database after event ID, for example, 100, you can select something after 100 from cold storage because that's the same event set. And you can see that when a donor is disabled, we can change it to cold storage without any negative effects, and it's really one of cool because we can work with both of these data storages in one time. We can switch any shards, we can switch database, we can test our migration, and we can try to understand how it works and how it's possible right now. So, the next one step, discovering the solution. You can see the list with 6 items, but the most important is chunk size, because other points just depends on this. Chunk size, define, download and upload speed, compression costs, encryption costs, and complete cost about development on this. If you choose a really too small chunk size, you have more costs for network communications, for processor and memory, just to compress it and encrypt, then you have an impact about this chunk size. Too big chunk size will make your chunk inefficient. When you pack, for example, 20,000 events in one chunk, you will download just for reading 50 events, all 10,000, and it's not so effective to decompress it and to encrypt and to store. How will we decide the main slice of migration? We need to make a short experiment to understand that our theory works, and of course we try to understand how many events we have for each pair of account subscriber. A little disclaimer. Our scope is account subscriber. Each our businesses its account, each subscriber. That's easy. Not a rocket science to understand. And that's our scope. So, we just collect the statistics and understand that we have average size of 17 events per each pair account subscriber. Maybe more, maybe less, but most effective by our using statistics that a lot of and a ton of our pairs of account subscribers has about from 16 to 18 events per pair. After that, we should understand just a little thing about the migration. And our discovering of solution make these decisions. We need to pack events to each chunk from 70 to 2,500 events in each chunk, more than max size of chunk going to the next chunk, less than going to a direct migration. Because less than 70 events in a chunk have more costs for migration and for reading instead of just reading it from relational database. And that's not interesting. We will use broadly for compression. This is algo based on LZ77 algorithm, maybe, but one of popular algorithms for compression data right now. And AES for encryption, because we need to any protection about unauthorized access of our data, we will use a disk storage, and of course we need to protect ourselves. And AWS S3 as a storage. We already use AWS as our infrastructure things for database instances and application servers, Redis servers, and more. ManyChat infrastructure based completely on AWS, so of course we decide to use AWS S3 to store our events in the chunks. I will be glad to tell you more about compression and encryption research, but it may be additional one representation about each of these things. Compression, really interesting case, and encryption too. But for encryption, this is just a usual case. AES use it right now in, for example, Chrome, Jinx, Apache, and a lot of things. This is like a standard. But broadly, this is really interesting thing. So we need only 35 minutes, and I just avoid this topic right now. And for continue our case, we need to have a migration data to understand how much we should migrate and how we can parallel these processes. And we need step-by-step migration. That's one of the important cases, because migrate the 64 terabytes of data to another storage, this is long process. This is really a long time. And we need to avoid any mistakes. So, after we write a chunk exposing to disks, we already start the migration to store this chunk to a disk and write compression. And if we really detect any errors, we can restart it, fix, and going next. Each step of this migration should be safe, repeatable, and each step of this migration should be independent of other. This is step by step by different workers to avoid any mistakes and don't start. Because if you union all of these steps in one worker, each mistake can be months costs of remigrate this data. But if we have any mistakes in upload or insert specific link events, we can just restart the steps to avoid previous. And that's interesting. So database should be really called. That's really important because it depends on the next one item about database capacity. Because if you work with a database in a middle or high loading, you don't have all resources to make this migration. Why it's important? Because we have a lot of data, and we should work with that efficient and fast. So in our case, when we have a really cold database with just maybe 16 requests each minute, we can use all of resources of this server, of this database, to migrate it to our custom storage. But if you have a little loaded database, you already have any risk in production because it may be overloaded. During our migration, database was overloaded to 100% to reading, and application servers was overloaded to 70% of possible. So, really cold database let us using all resources of these servers of this migration. And consistency control. We should be sure that everything okay on each step. We will talk about this a little later. Just keep it in your mind right now. So, migration data. Not a rocket science, as I already say. We have a scope of account subscriber, events count for each row. We should understand what we try to migrate directly or in chunks. Status for each step. That's information for each worker. Each worker, for example, you can on a row 2 you can see a chunk created status. It means that worker which will work with compression, selecting only rows with the status chunk created. Because first we selecting rows from database is stored as a file. Migration ID, that's our particular key because we did use experiment case. We migrated at 10% of data in the first time to understand that our theory works and it's okay. You can use it or not, but it may be helps because we use this migration ID next for using different servers for different migrations and different tables to parallel these processes and understand that everything okay. Step data, that's just a context field. For example, when we create the chunk and store it on a disk, we write to a context file path for a next worker which will compress it. And compression worker writing some context about compression data and any metrics and statistics. And metrics, it's technical things for first steps because we will use it for to avoid any bottlenecks. That looks like this. We had two information sources. We had logs and we had metrics in a database to compare results. You can see in the first row that we can detect that database has a lot of times to selecting rows. Compression and encryption have a low costs and uploading network costs is really up. Why should we use it? To avoid bottlenecks and less the cost of the times. For example, that's a chart about data migration and selecting rows from DB. To understand how to avoid bottlenecks with selecting from database, we made a little benchmark and discovered that after 300,000 rows per one request, we are out from a linear dependency from a count of rows we selecting and time, which we selecting was. So, of course, we decided to selecting only 3,100 rows max per one request and avoid the bottlenecks of this. For network cases, as I already showed, to uploading to S3, we just parallel these processes to free network because with the network we have different cases, of course, because costs depends on our configuration. For example, we can speak about keep alive of a network connections and waiting how S3 will call. Next one, consistency control. I already said we will talk about it, but you can check everything, but more longer process than migration, because with the migration you have additional steps to understand that everything okay is with your data. After first full consistency control during development, we can use a sample checking. Each 100 or each 1000 row can be checked with everything okay. It looks like you already selecting rows, place it on a chunk on a disk, and afterward you compress it, encrypt it, upload, make link events, and after that you download it, de-encrypt, decompress, reading, and understand that you have a same sets of events. And when you use it by a sample, you can avoid each 1999, for example, requests to understand that everything okay, because with the different states we have a different possible. Because we discovered it with the same things in the same servers, we have a different results. Sometimes you can have any problem with disk capacity or efficient troubles, and it can help you detect that everything okay or everything bad. This migration is really long, it's a month, and on this month you need to have any errors to understand. So, the last one, switch shards and disable database. As I already said, we have both storages, PosgtreSQL database, and our cold storage works in one time. And of course, when you end this migration, you need to switch shards before. We did it by flag. We can test it around to the world, as I already say, because it works everywhere. And we just switch shards by flag and test it in live. After develop, of course, develop server first, staging next, and production last one. It's the last one. The next one steps and just shut down the database and keep it shut down it, but not delete it for 1-2 weeks. Guess it's particular case for us because we had a lot of different workers and cron jobs, and that was like a safe point to understand that not one code point don't use this database exactly, and we just waiting for 1 week for errors, depends on these connections. And after that, you just drop a database, most scary things and most scary action. But everything was okay. So, how it works after migration? You have, I already said that we have a specific link events, but actually we have two. Each link event have a S3K, it's a pass on S3 storage to understand where should we download this chunk. First event ID link it to a reverse link event, timestamps range and size to compare it after unpack that this chunk, everything okay. This is for a lifetime consistency control. And reverse link event, which link it to a direct link event with the last event ID in JSON data. But why do we want to have exactly two link events? Because when we use it in a PostgreSQL database, and I should explain, with usual events which we store in a PostgreSQL database, we have a specific link events about our migration. That's just a link to S3. We should understand that with events with a specific type of cold storage, we should unpack it, download before, unpack it of course, decompress, decrypt, and have this full set which we already store in a chunk. And when you scanning this events deskadin, okay, if we have only one link event, we will corrupt one of this scanning. Because we're, for example, selecting here, try to imagine that we have only one link event with the ID 16. If we are selecting events from here and selecting first 5 events like 15, 14, 13, 12 and 11 and asking for a next, we didn't find any events because we are searching events after ID 16. But we don't have events after ID 16 directly PostgreSQL database. But when we use directly into event with ID 6, we always will be stopped on this and unpack and continue. This is stateless decision to have all, how did I say it, just to always selecting event 6 till we selecting all events from this pack. But in a reverse case, we're going from the oldest events to newest and going to a 16 event ID. That let us work without keeping any states in a cache or understanding where we place it right now. The next one, any post-factum decisions. We discovered we have any hot accounts which selecting all of our events from each database and always, each day and each time, few accounts just selecting everything to understand what they should do. We don't have API for works with our events. And there's big accounts just selecting our backend endpoints to download all events about their subscribers. And of course, we just unpack it back and migrate it reverse directly to understand that we avoid additional requests. You can see that we have a small statistic about this. So that was one of the reasons because we should migrate it. You can see that it's about 500 requests each 15 minutes for this storage. And when you keep it in a PostgreSQL instance with a 64 terabytes of data, you have a very powerful instrument to use it for very cheap and useless cases. Next one, it's event source. That's maybe a little useful for a support or your debugging cases when you understand which events you got from any storage. And runtime consistency control, when we understand that everything okay. That's not a sample, that's of each chunk we have, because after a few cases, when we have a specific chars in a JSON, and we need to understand that everything okay. For example, you can forgot that you should install specific libraries and on the server if you don't have any states. And that maybe return 0 events. But when we work with event databases, we try to avoid this checking. The next one, little design mistakes. Our S3 chunks passes without DBID. Why it's important? Because when you make next migrations, in any mistakes, that's a really easy way to remove the particular directory, core directory, and root directory, instead of checking which exactly chunks you are placed from which exactly database. That's a little easy to remigrate any mistakes. Migration to a production database, that's completely safe because we design it like a really safe point, but it's a little difficult to understand what did you already migrate and what you should go to next. It's more easy to use an Azure schema or another database to migrate the new database to chunks and after that just directly inserting. And the one little mistake. That was interesting case because when we try to test steps about compression and encryption, synthetical data, that's not a synthetical data actually. In fact, this is real data, but a very short slice. Because this slice, you can test, if you will test the steps position for 64 terabytes of data, you will have more than migration times to understand more what should be efficient. So we just use a sample, and this sample shows us that we should first encrypt and after that compress. But when we finish 30% of migration, we discovered that we up our disk allocated space up to 3 times on the next migration about this decision. So we just rotated, and right now we know that our real data have a different state with a synthetical sample more than 0.1%. So we had a remigration price about this because that's like a completely remigrate full data which you already place on S3 and write it to link events. And of course, that was about 3 months, I guess. So keep it in your mind when you do some additional decisions and test it on a real data. I can recommend at least 10% of your data to have a representative. One of big plus, yeah. Because I already said that testing everything in each chunk of your migration, it's really expensive. But we did it because we should have a remigrate completely one of databases. And of course, that means one plus. We really did check everything of our migration and understand that we had a 99 dot, a lot of nines after this dot, percent of data quality and migration success state. Right now, we have a simple, stable, and cheap storage. Works parallel with our component, which works with Event database. We decreased annual costs from almost $500,000 to a little more than $8,000. Total saved after first migration more than $500,000. Our scale repeatable because we already migrate in this schema-free databases. We don't have any difference in uptime. We don't have any difference in querying, and we don't have any difference in data quality. And after metrics, you can see that before in free databases which we already migrate, we have 226 terabytes of data. After first DB, which has a size 64 terabytes, has been compressed to almost 10 terabytes of data. And free migrates right now keeping 34 terabytes. First request time. This is big numbers, but please keep in your mind this is what mattered from a browser, because we have a few layers of preparing this data, and because this is different components, we should compare how it works just to a break for our front end and analyze it in a JSON. So our price before $55,000. First database has a price, it's almost 200 dollars, and currently storages for our free databases on Events has a price about $700. A little questions which I already got from a few engineers. They said that we can compress it more. I agree, we can with another engineering, and I guess it's not few hours. It's even if we have a few days, it can be more expensive with $200 for first database storage. And that's just, that we can do it, but that's no matter, because that price will be more expensive. This development will be more expensive than this storage. We can merge small chunks of several subscribers of each account and keep it more or less. I guess we can, by my calculation, we can store each of these databases for $500. Or $500, no, $50. With using any algorithms of compression, any levels of compression, merging any chunks and merging some subscribers, we can make it less. But no one engineer has a price of $20 per month, and this is useless too. And normalize, but that's what's strange, because event database should be denormalized. So that's all. If somebody have any questions about this, I can respond.
Right, thanks a lot for your presentation. Now, time for questions. Right, gentleman over there.
Thank you very much for the talk. So, I've noted the very good systematic approach to the problem, and I have a few questions actually. So the first one is it a rule to follow in the ManyChat company that you should plan ahead everything you do and write down a list of steps you want to do, or is it for this task only?
I guess it's a post factum. Right now I have this list.
All right.
But during development, there's just native actions about that. So about currently this presentation, about currently these steps in ManyChat, we don't have a previous architecture and completely understanding what should we do. That's just one of infrastructure engineer going to work with tasks, and
All right.
that's
Okay.
all.
Can you highlight the timing of this approach stages? So the planning, then the getting costs, etc., etc. So we understand what took the most time and what took the least time, and what is the distribution.
2 days for a few meetings in infrastructure team to understand what should we do. Just what ideas we have and which one we choose. Next, about 4 days to get metrics because this is big databases and we shall just waiting when it's collected. And about 5 months of first migration completely because we're just waiting. But actually, that's not a lot of code, a lot of control.
Okay, thanks. And the last question is, do you think that applying the similar approach with the steps of what should be done and this level of analysis should be applied to every task in the company?
Not completely understand. Can you...
Well, I mean the systematic approach, so collecting metrics, analyzing, writing down steps, discussing it before the implementation.
We have any possibilities in infrastructure team to not collect this data and make our own decisions by engineer. So that's not systematical decisions and systematical solutions. That's just, okay, our sync looks like this. One of the week, we just have a meeting in 1 hour when we talk what we did in the last week, and next time we will talk next week.
Right.
That's not like reports, what we did, and our engineer in our infrastructure team can make their own decision without any agrees and without any plans and without any lists. We just had the metrics and automatically works.
Okay, thanks.
Excellent, thank you. Any other questions, please? Over there at the back.
Thank you for the talk. Actually, I don't know what is the structure of the event in your case, but I suppose it should be rather stable structure. But have you considered what would happen if you need to modify the structure of your event and so that it's no longer compatible with the data you archived?
So, first, classic events database should be not updated never. This is read-only state. You write it one time and you save it forever. But of course, we have cases like GDPR requests from our customers when we need to delete it and update any events, of course. Technical events actually, not a user events. And we can unpack it, rewrite, and pack it more. We have just a little code to work with these events because we have a parallel and very same interfaces components which works with one of sets, and a component who should update, which should update this pack of events or any particular event, can download it and work with that like a result set from a PosgtreSQL database. That's not a rocket science, it's easy.
Okay, thank you.
Excellent. Anyone else? Right, over there.
Did you consider any solution instead of grabbing the whole chunk and checking inside this?
Excuse me, I almost don't listen.
Sorry, is it better?
Yeah.
So, as I understand, to get some info, you have to grab the whole chunk. Next, you search inside this chunk to find some info. Did you consider asking S3, for example, with S3 select to do the job for you and to just execute all the queries inside S3 and get only the results?
Usually in our use cases, we use a whole chunk to return it to the front end because it's not a big filtering because we have just messages history and any states. But particularly, of course, we can scan. As I already said, we have a little chunks and average status is just 70, and we can download all of this to understand. But For more fast actions, we of course are caching these events in Redis for 15 minutes for continue chatting and continue scrolling the chat, and store this file of chunk on a disk for 24 hours for next access, because usually customers are returning to this subscriber a few times during the day. If they already work with him, they should work with him a few times after. So our hot events has a hot state on our application servers and cache in Redis, of course. But for reading everything and filtering everything, that's not a rocket science and not a big costs, because that's not a PostgreSQL database. PostgreSQL database have a phonetical and topological analysis, query planning, QA of queries, any interface after vacuum, and more and more and more and more. That's just a download a little chunk, less than, by our metrics, that's less than 1 kilobyte of data. That's really fast. That's really easy. That's really cheap by costs, and we can remigrate, rewrite, and analyze all of these events without any troubles. But to solve these cases, actually, we have analyze databases in our analytics team. They have a copy of these events, and they can work with our storage both.
Thank you.
All right, thanks. So, last call for any questions. And you have been here for 2 days. You know the rules of the game. Questions might earn you valuable prizes, right? So, anyone? Oh yeah, sorry about that. Didn't notice.
Thank you. I have one more question regarding how you form the chunks. Do you keep the events per user, per chat group, per channel, or something like that?
That's for account and subscriber only. I already said that we have something here. One more. No. Like this. Account and subscribers, this is scope. And we made chunk for account and subscriber. And by sizes, we already decide chunks placed for account.
So that was the different lookup table to use in case there are some GDPR deletion request or something like that?
GDPR request based on exactly subscriber. Subscriber, it's a person. And if some person requesting GDPR deleting their data, we just delete exactly chunks of this account and subscriber.
Okay, so you are doing the lookup on the table to understand what are the chunks for these specific
Yeah, of
subscriber,
course.
and
We
then
have a
remove from
link
S3.
events which write on like account, subscriber, chunk address on S3, and type called storage.
Okay, thank you.
Right, thanks. So, really last call. Any remaining questions at all? No? Well, no. Over there. Right. So, really last call.
Do you have some sort of search in your system?
Yeah.
And how it works in old cold messages
Download chunk, read this chunk.
for all your chats?
No. That's not for all. We can use it for all chats. That's really not an often case when people searching for all of chats. Usually it's searching in a particular subscriber, and that's not really hard for us to read in this chunk.
Do you have for all chats?
I can do it, but
So you can do it, but
yeah.
do you have it right now?
okay, we can these functions, we can this mechanism, but our customers really using it not so far. It's that's not an ordinary case for them, not for us. We have this mechanism. That's not a really
You don't have a
difficult.
group chats.
Group chats? No. That's a marketing automation. They work with their customers, and they don't have a group of customers.
Yeah, I see. Thanks.
Right. So, now, the fun part. You have to decide which question was the best in your opinion, and the author of that question gets a prize. Now, we didn't have any questions online, so that's only this room, please. So, your choice.
I guess, sir, from the side, in a gray suit.
Vasily, are you sleeping?
Yeah.
You won a prize! Right, so
Yeah,
thanks
thanks.
again for your presentation.
Thanks for you
And,
guys.